Hello. So OpenAI today during Dev Day released a bunch of new updates to their existing APIs and improvements, but they have also released a assistance API, which I have built a Cloudfare TypeScript boilerplate project for, where which you can find under I'll attach the link, but you can also just search for OpenAI Assistant Starter and I will show you what the project, how the project looks like. But first, I will just show you where the documentation is for these assistants. It is under documentation. So if you just go to Platform AI, um, it will be right here. Assistants deep dive, I believe. Yes, and it will explain how the assistants roughly work. The idea is there's this notion of threads, which basically is just a collection of messages, and then you create a separate assistant with a system prompt, and then uh, certain tools that it can have. And tools basically is just a fancy way of saying it's either functions that OpenAI hosts for you. So, for example, it can call Dale image drawing APIs, or it can use code interpreter. But you can also implement your custom functions, custom tools. And this is what I have in my example project already set up. So you can just use that, and then you can create your own custom tool yourself. That will, like, my custom tool right now is really dumb. It just adds two numbers, but you can replace it with an API call. I decided to just not make it more difficult than it more complicated than it needs to be. All right, so you can read through this uh, documentation. The reason I created this project is it gets like you need some boilerplate code to get this thing running, as you will see in a moment, because it used to be that you just submit messages to OpenAI and you just get the message back. And now you need to create an assistant, you need to create a thread, you need to add a message to the thread, you need to create a run, you need to pull that run to see how the run is doing, and you need to like continuously check on it. And then the run might be in this interrupted state where it's waiting for your tool to be called, where it's waiting for your tool to like execute, and it gives you the parameters to the tool. And yeah, so there's basically a bunch of piping that goes into like building, like having this run end to end. And this is what I was curious to try, and this is what it's doing right now. All right, so this thing is also very useful. So if you go to Playgrounds, which is up here, you can create your own assistant, and this is actually like, I believe it will list all the assistants. So this is actually the assistant that I created through the API. So it was not created through the playground. It's created through the API, and you can see this at function at numbers, and that's the tool that we're exposing. And you can see in a second how this tool actually gets invoked in our Cloudfare worker. Let's see. Now if we go to playground, and we can just see how this would roughly work. And let's see, add, let's come up with a crazy number and another crazy number. And the idea is without the tool, it will not be able to come up with the correct answer. But if we give it the tool, it will actually be able to add those two numbers. And right now, this just like simulates the tool execution. So I can just say like, let's say this output is like something like this, right? Like it's probably like, it's definitely wrong, right? But like you simulate it, and then you can see this logs of what, like, interesting. So it actually decided not to copy, not to use what I gave it as the answer. Maybe it just knew that this is definitely, like, it just knows that this is definitely wrong. It's not the point. The point is that it has decided to use the tool, and like you can expand these things, and you can see them coming in real time. You can hide the logs and show them right here. And yeah, so this is how their interface looks like. And what I have built is essentially a backend that executes these API calls when you submit a message to your assistant. And the assistant is currently hard-coded. So let's take a look here. So what I'm using is I'm using OpenAI, I'm using router, and then we're using Cloudfare and Miniflare to debug locally. And I'm using Miniflare too because it supports breakpoints within VS Code. So this is why I chose it. Let's take a look at let's first take a look at the test. So I've also bootstrapped the test here. So the first test is, can the assistant say hi to me? That seems pretty basic. And what it does, there's two endpoints that the API exposes. One that creates a new thread, and we can get the thread ID like this. And then another one which posts a message to a thread, and it then gets back the response. And in our case, we expect this response to be hi. So essentially, two things: create a thread, post a message there, and basically we just instructed like, hey, just tell me hi, like that's it. Please don't do anything else. Just plain hi is good, and then we just make sure it runs. And you can see like this is actually posting to our local host, Cloudfare worker, and so this is a sanity check that the basic assistant works. And let's now take a look at what code needed to be written to get this to work. So we open the assistant. So there's some hard-coded strings. The name of the assistant is how it knows whether to create a new assistant or not. So let me hide this. So the first endpoint that gets hit is very simple. It basically just creates a thread. So you're using this OpenAI beta threads, and then you just create it, no parameters required, and you just return it back as is, thread ID, right? Nothing interesting here. Now the router post messages, that's where things get more interesting. So first we get the thread ID, it's in the route, and then we get the request body, which is the text that the user, the message that the user has submitted to add to the thread. And notice how we will not need to manage the thread state at all, which is really nice. So the API used to be stateless, where you just supply the entire set of messages, which is like good and bad at the same time. Like this now you need to do more things, but at least you don't need to store the data whatsoever. It all gets stored by OpenAI. Okay, so the first thing is we list all the assistants we have in our account, and we check if we find an assistant that has the name. So if you have already, if there's already an account, if there's already an assistant that was created by one of the previous runs with these configurations, it will just reuse that assistant. Again, not super robust, but whatever. This is a starter project, right? That's the point. So if there's no assistant, we create an assistant, and we pass it. Importantly, we pass it the tools, which basically describe how, we give it a function tool. We say that the name is add function, add numbers. We give it the parameters, and then we tell it which parameters are required. And this tells, when we're going to run the assistant, it will have the option to call this tool. And this is what tells it what shape or form the tool is, and how to submit, how to actually invoke the tool. Now we have the assistant, right? We either looked up the existing assistant or we have created a new one. Now we create a new message on the thread, which we actually don't need assistant for. So we create a new message on the thread. This is pretty simple. And notice I don't actually get, I don't care what this returns, because you'll see in a second, I'm not actually submitting the messages. I'm just saying hey, for this thread ID, actually right here. Then we run the assistant on the thread by just giving it the thread ID, and we're saying, hey, create a run using this assistant on this collection of messages. And this collection of messages we have just appended our user request to. And here is where the magic happens. So there's this do while loop, which is, I guess I don't oftentimes do while loops, but ChatGPT actually, ChatGPT wrote majority of this code, and I've provided it like this assistance documentation, which you can take a closer look to. I have basically created this prompt with all the files above. So this is just a gigantic file with all the documentation. Like it has, also these lines are like kind of long. Like it has, I forget, it has like 16,000 tokens, I believe. So I just copy pasted this into ChatGPT and it generated not this, but like a good starting point. And then I made adjustments also using ChatGPT. All right, now going back to the polling. So now that we have this run, we now need to poll the run periodically, checking what's the status of the run. Like, is it running? Is it completed? And more importantly, is it, so in the beginning, we're just going to wait like for this first test, right? We don't really need much. We just need to keep running this for loop, which just delays for 1 second each time it runs. And once it's completed, we don't need to do anything. We then retrieve the messages that the assistant added. And the idea is like if we just added the user message, the last message now, once the run is completed, should be the message from the assistant. And then there's like a bunch of just making sure we get not the actually this should be oh no, this was correct. Oh my god, I should not have tried doing that. Yeah, so if this is not the assistance message, we say like we're gonna crap out. Then if this is like if no message was found, blah blah blah, like some checks, and we finally return the assistance response. All right, so let's run this again. I have added a breakpoint right here, which is the loop where we are polling the run. So we've created the run and then we will be polling it continuously. So now let's step over and then you can see the complete run. You can see the instructions. You can see the tools that it got. You can see that the status is completed. So we only want the status. We only really care about the status. And then you can also see that there's requires action, which we'll see in a second. So if you step over this, it will just go through and then it will break out of this because it's completed and then the while loop is just done, right? Now we can see, now we're getting the messages and you can see there's 2 messages. And the important thing is the top message is actually your latest message. So you can see here the assistant responds with value high. So that's expected. And then we can, play all the way through. And then, this will just be high. So that's great. Now let's play. And it will hit the second test right now. Yep. So the second test is where things get more interesting. So in our request body now, I'm asking it to add these 2 big numbers and only reply with the answer. So in this scenario, it will actually want to use a tool. So right now, if it looks at the completed run, it will say that it requires action. So we have waited and then we've polled and we check the status and it says it requires action. Requires action means that we need to get our get our tool and actually use it. So what this looks like in here is there's this required action field which type submit tool outputs, and then there's the tool calls, which is an array of all the tools that were called. And so the arguments are just a string that we parse and we then will pass it to our add numbers tool, which we have declared previously right here, which basically just fake delays, adds the numbers and returns the numbers. So now we will step over and now we're in this if statement. Let's keep stepping over. Now we are in actual invocation of the thing. So you can see the args here is AB, and then we now get the result. And now that we have computed this custom, the custom tool has been executed. Now we will submit it back to the thread as essentially another message. No, I guess this we're submitting this to the run. Right. So we're submitting this to the run, and the run is for a specific thread ID. So now let's step over, and we get here again, but now this is empty or something, and then the status is also requires action. That's interesting. Oh, okay. We went to this for loop back, but it's a single call, so we got out of the loop. And here we're just continuing polling, so we don't want to get to this status. We basically just we just continue. And now if we play again, you will see that we are back into the polling mode, except now if we ask if it's completed, the run will indeed be completed. So this will now go here, and now the status is completed. That means the run is completed, and there should be a final message, similar to how we have seen in the past. But now, instead of just having a simple hi, it will actually have the value, this thing right here. And if you look at our tests, so if we keep playing this, this will return. And if we look at the test that got us here, this is what the test looks like. We create two numbers, we create a question. So I probably should have started with this. We create two numbers, and then we post a message to our thread asking to add those two numbers, and then we get the text back, and then we verify that this is actually, the text matches what we have computed on our side, and it indeed does match, hopefully. So let's just run this. Let's continue running this, and you can see, yep, 2 tasks have passed. Now we can safely quit this, and this concludes the video. Ta-da! I'm excited to see what you can build with this, if anything. But I have at a hackathon previously used some boilerplate with Cloudfare Workers, and we have built the Show Me ChatGPT plugin for diagrams, and that starter project was actually quite helpful for us to finish this in time. So hopefully this will be also useful for someone, similar to how the plugin boilerplate was useful to us. All right, thank you for watching.